Imagine what you'd see if you had a lens the size of a galaxy. Well, believe it or not, galaxies themselves can actually act as lenses. Astronomers all over the world have been left scratching their heads as the James Webb Space Telescope detects 6 new galaxies that should not exist. With a telescope, astronomers and scientists can literally go back in time and see how galaxies were formed over billions of years, but no one was prepared for what they saw recently. 6 previously undiscovered galaxies that threaten to destroy established cosmological theories and ideas. Scientists have declared that these discoveries are technically not supposed to exist, defying established laws of science. What are these new galaxies? How did the James Webb Space Telescope find them? And what are the implications of these discoveries? Join us in this video as we explore how the James Webb Telescope detected a structure that should not exist. The study of the universe on its grandest scales, which is the realm of cosmology, is an exciting and ever-expanding field of inquiry. As our technology advances, so does our ability to probe the depths of space, revealing new and awe-inspiring wonders. At the forefront of this cosmic exploration stands the James Webb Space Telescope, named after the astronomer James E. Webb. It is the largest and most powerful space telescope ever built. Its primary mirror, a gigantic structure measuring 6.5 meters in diameter, comprises 18 hexagonal segments that unfold like an origami flower. This immense mirror, combined with its advanced infrared sensors, allows the James Webb Space Telescope to look back in time to the very beginnings of the universe. It captures light from the first galaxies that emerged just 250 million years after the Big Bang. The James Webb Space Telescope's mission seeks to transform our understanding of the universe. It aims to unravel the mysteries of the universe's formation, shedding light on the birth of stars and galaxies, the evolution of cosmic structures, and the presence of potential habitable exoplanets. By observing distant objects that emit light in the infrared spectrum, the James Webb Space Telescope can penetrate dust clouds that obscure visible light, revealing hidden depths of the cosmos. The discovery of new galaxies holds immense significance in the realm of cosmology. Each newfound galaxy represents a piece of the cosmic puzzle, providing clues about the universe's composition and evolution. By studying these distant galaxies, astronomers can gain insights into the formation of stars and planets, the distribution of dark matter and dark energy, and the overall structure of the universe. The James Webb Space Telescope's ability to detect faint distant galaxies has already yielded groundbreaking discoveries. In July 2022, the telescope captured images of galaxies that existed just 620 million years after the Big Bang, the farthest galaxies ever observed. These observations push our understanding of the early universe to new frontiers, revealing the first galaxies that emerged from the primordial chaos. But what makes this telescope special and amazing? The James Webb Space Telescope is the largest and most powerful space telescope ever built. It is an infrared telescope, meaning that it is designed to detect light in the infrared portion of the electromagnetic spectrum. The James Webb Space Telescope's primary mirror is 6.5 meters in diameter, 3 times larger than the Hubble Space Telescope's mirror. This means the JWST can collect 4 times as much light as Hubble, allowing it to see fainter and more distant objects. The James Webb Space Telescope is also much colder than Hubble. This colder temperature allows its infrared detectors to operate more efficiently, making them more sensitive to faint infrared light. Hubble operates at about -123 degrees Celsius, while the James Webb Space Telescope operates at -218 degrees Celsius. The James Webb Space Telescope also has 4 scientific instruments, each of which is designed to study a different aspect of the universe. These instruments include the near-infrared camera, designed to take images of the universe in the near-infrared spectrum, which is the portion of the infrared spectrum closest to visible light. The near-infrared spectrometer, a spectrograph that will be used to study the spectra of objects in the near-infrared spectrum, allowing astronomers to measure the chemical composition of objects and to study their motions. The mid-infrared instrument, designed to take images of the universe in the mid-infrared spectrum, the portion of the infrared spectrum farthest from visible light, and used to study specific objects such as dust clouds and stars in the early stages of formation. And the fine guidance sensor and near-infrared imager and slitless spectrograph, a combination of two instruments that will be used to keep the James Webb Space Telescope pointed accurately at its targets while taking images and spectra of objects in the near-infrared spectrum. The James Webb Space Telescope is also a significant upgrade over the Hubble Space Telescope, allowing it to study a different part of the electromagnetic spectrum than Hubble. Hubble is an optical telescope designed to detect light in the visible portion of the electromagnetic spectrum. The James Webb Space Telescope, however, is an infrared telescope designed to detect light in the infrared portion of the electromagnetic spectrum. As part of its mission to look back in time and observe the origin, nature, and formation of galaxies in search for exoplanets, the James Webb Space Telescope has recently discovered 6 new galaxies. These newly discovered galaxies have captivated the attention of astronomers worldwide, offering absurdly improbable glimpses into the earliest days of our universe. These galaxies, described in a new study based on Webb's first data release, are so far away that they appear only as tiny reddish dots to the powerful telescope. By analyzing the light emitted by these galaxies, astronomers established that they were viewing them in our universe's infancy, only 500 to 700 million years after the Big Bang. Such early galaxies are not in themselves surprising. Astronomers expected that the first star clusters sprung up shortly after the universe moved out of the period generally referred to as the Dark Ages, about the first 400 million years of its existence when only a thick fog of hydrogen atoms permeated space. But the galaxies found in James Webb images appeared shockingly big, and their stars were too old. According to experts, the new findings conflict with existing ideas of how the universe looked and evolved in its early years and don't match earlier observations made by Webb's less powerful predecessor, the Hubble Space Telescope. In the words of Joel Leha, assistant professor of astronomy and astrophysics at Penn State and one of the authors of the study, we had specific expectations for the type of galaxies that live in the early universe. They are young and small. Previous studies of the early universe with Hubble and other instruments tend to find small blue baby galaxies at early times, objects which have just recently formed out of the primordial cosmic soup and are themselves building their early stars and structures. In general, young stars shine bright blue as they age. These stars develop a red glow as they burn through their fuel and cool down. But in the ancient galaxies that Webb was built to spot, astronomers had not expected to see old red stars. They also had not expected to find galaxies more massive than perhaps a billion suns. But those reddish dots revealed in Webb's deep fields appear 50 times more massive than that. The most massive galaxies in our sample are expected to have masses 2 to 4 times lower than that of our own Milky Way, Ledger said. Scientists were thus shocked to find out that some of these galaxy candidates are as massive as our own galaxy when the universe was just 3% of its current age. Ledger said that before astronomers start rewriting cosmology theories to explain how these galaxies came together so quickly after the Big Bang, they will have to ensure the odd red dots they are looking at and not something else. Most of the alternative explanations, however, also require entirely new concepts. For example, stars in the early universe might emit light in exotic ways due to their lack of heavy elements, and perhaps we're not incorporating those in our models. Or alternatively, perhaps our understanding of how stars form locally, for example, how many stars form from gas as a function of the mass of the stars, is totally inapplicable in the early universe. These things would also be exciting to discover and would also overturn our understanding of star formation in the early universe, just in a very different way. He added, "The most important thing is that spectra give very precise distances to these objects," said Ledger. According to the study, the distance and the identity of these objects are correlated. If we know the distance, we can pin down the identity and vice versa. So, a spectrum will pretty immediately tell us if our hypotheses are correct. These discoveries are as amazing as they come. To have scientists already challenged to rewrite their theories about the early universe just a little over 6 months after the Webb team released the first observations from the Grand Observatory is unthinkable. Ledger said that while the objects so far do appear to be galaxies, there is a real possibility that some of the entities they found could be supermassive black holes. Black holes are areas in space where a large amount of matter is packed into an area millions of times as massive as the Sun, and where NASA says gravity is so strong that nothing, not even light, can escape. But even if it turns out that some of the 6 objects they found are black holes, it still shows an astounding change, according to experts. Regardless of subsequent reporting, The amount of mass discovered shows that the known mass in stars at this period of our universe is up to times greater than scientists had previously thought. The idea that massive galaxy formation began extremely early in the history of the universe upends what many astronomers had thought was settled science. According to the study, they have been informally calling these objects universe breakers, and they have been living up to their name so far. In a later statement made at Penn University, Ledger said, "We looked into the very early universe for the first time and had no idea what we were going to find. It turns out we found something so unexpected it creates problems for science." It calls the whole picture of early galaxy formation into question. So what are these galaxies found deep in the cosmos field, a region of the sky teeming with galaxies? These newfound celestial bodies have become the wonder of astronomers as they challenge our understanding of galaxy formation and evolution. The first galaxy is a remarkably compact and massive one designated GNZ11. It holds the distinction of being the most distant galaxy ever observed. Its light, traveling for over 13 billion years, reached Earth when the universe was just 330 million years old. Despite its early formation, GNZ11 is surprisingly compact, with a size similar to our Milky Way galaxy. However, in a shocking and puzzling turnaround, its mass is 89 times greater than that of the Milky Way, belittling everything we know about galaxy formation. The second galaxy is named GZ10, and is located approximately 13 billion light-years away. It exhibits a level of brightness that is beyond what astronomers expected to see, outshining theoretical predictions by nearly 100 times. This has caused astronomers to suggest that it may house a population of stars forming at an accelerated rate. This phenomenon could rewrite our understanding of the early universe's star formation processes. The third galaxy, GZ9, is situated about 13 billion light-years from Earth. Similar to previously discovered ones, it also showcases abundant heavy elements like oxygen, carbon, and nitrogen. These elements, essential for life as we know it, were forged in the hearts of massive stars that exploded as supernova, enriching the surrounding interstellar medium. The presence of heavy elements in this galaxy suggests that star formation and supernova were already occurring in the early universe, a crucial step toward the emergence of life. The fourth galaxy, designated GZ8, located around the same area as the previous one, has a remarkably structured disk, a feature that challenges existing